Okay, good morning. We have a problem, a mixed RLC circuit, and numerical data is valid for the whole problem. Is L1 is 0.075 Henry, R1 150 ohms, R2 is 250 ohms, and C2 is very variable. After giving C the value of 8 microfarad, supply the system with the supply of the system is sinusoidal current of pulsation of omega 1000 radian per second, and the value of the RMS current is 0.1 amps. We are asked to calculate the complex numerical value of the impedance Z1, Z2 here. Calculate the complex and RMS values of the following three voltages: V1 or VA minus VB, V2, which is VB minus VD, and the total voltage, which is equal to VA minus VD. And draw the vector diagram of the three voltages and check the RMS value of V. Okay, let's start. First of all, we calculate the impedances of this circuit. Z1 is equal to R1 plus G X1. X1 is equal to L1 times omega. It's 0.075 times 1000, and it's 75 ohms. Z1 is equal to 150 plus J 75, and in polar form it's 167.7, and the argument is 26.56 degrees. Let's calculate Z2. Z2 is R2 times minus JX2 over R2 minus JX2, and it's equal to, first of all, X2, it's 1 over C2 times omega, it's 1 over 8, 10 to the power minus, it will be plus, times 1000, and this is 1000 over 8, and it's 125 ohms. We can write that this one is 250 times 125. The argument is minus 90 degrees, and here is 250 minus J 125, and the result is 279 here. Argument minus 26, 565, and the numerator is 250 times 250 times 125, here minus 90 degrees. The result is Z2 is equal to 111.8, and the argument is 63.435 degrees. From this we can calculate the equivalent impedance is Z1 plus Z2, as it equal to Z1 150 plus J 75 plus Z2, which is equal to, I didn't write it, Z2 is 50 minus J 100, 50 minus J 100, and this is 100 100. It's 150. Just 25 minus. This is 100 and plus minus J25. And the result is it? This one is plus 50, so it means it's 200, and the result is 201.55 and minus 7.125 degrees. From here we can calculate I is equal to 0.1, this is equal to V over Z, the equivalent resistance. So it means that Z 201.55 minus 7.125, so it means the current is equal 0.1 plus 7.125 degrees, and V is equal to 20.15, and here 0 degree. So we can now calculate V1, V2. We have V here, V is equal to 20.15, 0 degrees, and here we can calculate the rest. V1 is equal to Z1 times I, V2 is equal to Z2 times I, Z1 is 167.7, argument 26.56 times 0.1 times 0.1, 7.125 degrees, and the result is 16.77 and argument is 33.68 degrees, and here it's Z2 111.8 minus 63.435 times 7.125, and this one 11.18, and the argument is minus 56.31, and V we calculated earlier, 20.15, 0 degrees, and we can draw the vector diagram. This is V. V1 is 16, this is V1, V2 is 11, and the sum of the two, I have to correct this. This is V, this is V2, and I is leading the voltage, and it's I here. We draw the vector diagram. Now we have to do the next question. Next question is this. The capacitor C2 is now variable and the system is subjected between A and D to a voltage V of RMS value V, and pulsation is 1000 radian per second. Determine the value or values of C so that the current through the system is in phase with the voltage. Calculate the value of I if V is equal to 24 volts. Okay, let's, if the current and the voltage are in phase, the equivalent impedance, which is we have calculated before, R1 plus J X1 minus J R2 X2 over R2 minus J X2, and if we can write it this way, R1 plus J X1, we eliminate the imaginary part in the denominator by multiplying this by the conjugate, and we obtain R2 squared plus X2 squared. The result is R1 plus X2 squared R2 over R2 squared plus X2 squared, and the imaginary part is the following: X1 minus R2 squared X2 over R2 squared plus X2 squared. And if you want that the current should be in phase, it means that the imaginary part should be 0. So it means x1 minus R2 squared X2 over R2 squared plus X2 squared should be equal to 0. And we try to solve this equation, and this equation is x1 times R2 squared plus X2 squared minus R2 squared. X2 should be equal to 0, and from this equation we try to solve for X2 squared, for X2. So this result is x1 X2 squared minus R2 squared X2 plus x1 R2 squared equal to 0. We have a function, quadratic function of this form, and we have to solve. Delta is b squared minus 4ac x1 and 2 should be minus b plus or minus square root of delta over 2a. Here we have 75 x2 squared minus r2 squared x2 plus x1 r2 squared equals 0. If we divide by 75, x1 is 75, r2 squared is 75 x2 squared minus x2, and here plus this value of c equals 0. If we divide by 72, we have something like this. 75, if we divide, we'll have x2 plus 62,500 equals to 0. This is squared minus 4, 62, 500, and square root of delta will be equal to 66667, and from this we calculate x2 is equal to, first solution is 2, x2 is equal to 750 ohms. A second solution, if we write 1, 2, is 8 minus 66667 over 2, and this will give us 83.33 ohms. And from this one we calculate C2. One of them is, first is 133 microfarad, and second one is 12 microfarad. So from this we can calculate the current for V equals 24 volts. For V equals 24 volts, we have two values of the current. because we have Z is resistive and is equal to R1 plus X2 squared R2 over R2 squared plus X2 squared. First value, if we put X2 equal 750, we'll get something like that. 250 over 250 squared plus 750 squared. This will give us 375 ohm. And second solution is 150 plus 83.33 squared times 250 over 250 squared plus 83.33 squared point, and this will give us 175 ohms. Current is equal to V over Z equivalent 1, so 24 divided by 375 and 66 milliampere. And second value, E is V over ZA2, as it's 24 over 175, will give us 137.14 milliamps. And thank you very much. I finished and we solved for everything. Thank you very much.